In example 4b, we are still going to be evaluating a function, but we have changed the function. The function we're going to be working with now is g of x is equal to 2x plus 1 all over 3x minus 5. So this fraction. So in part 1 here, we're asked to find negative g of x. All right, so the name of this function is g. So we've seen something like this before back in example 4a. Remember what this means. The minus sign is on the outside, okay? So when you look at this, look inside parentheses, this is what you're going to replace x with. Well, here you would be replacing x with x. There's no change there. So the only thing you have to deal with is this negative on the outside. We learned that this means this is the same thing as negative 1 times g of x. So all we need to do is multiply the function by negative 1. But this can be tricky because it's a fraction, okay? So let's talk about how you would correctly multiply a fraction by negative 1. All right, so here we go. Negative g of x, that just means we're going to take negative 1 and multiply by the fraction. So we're going to multiply by the fraction here, 2x plus 1 over 3x minus 5. Okay, the question is, how do you simplify this? Okay, do you multiply the top and the bottom by negative 1, or do you just multiply the top by negative 1? What do you do? Okay, well, let's reason through this. So this, the 2x plus 1 over 3x minus 5, that is a fraction. So let's make the negative 1 a fraction as well. You can make anything a fraction by putting it over 1. Okay, so negative 1 divided by positive 1 is still negative 1. Okay, and then hopefully you remember how to multiply fractions. To multiply fractions, you need to multiply across the top and you need to multiply across the bottom. So if we multiply the numerators together, we're going to get negative 1 times the quantity 2x plus 1. You have to put that 2x plus 1 in parentheses because you're going to have to distribute that negative sign. And in the bottom, we're going to have 1 times 3x minus 5. Okay, and so now we simplify. In the numerator, we can distribute the negative sign. So we're going to get negative 2x minus 1 over, in the bottom, anything times 1 is itself, so the denominator will remain 3x minus 5. Okay, so here is the answer. Okay, you can see what happened here. We ended up multiplying the numerator by negative 1 and the denominator stayed the same. Okay, now hold on. There's a couple of ways to actually do this. Okay, let's think about it this way. All right, so again, if you are forming negative g of x, okay, all you have to do is multiply the function by negative 1. Okay, so I'm just showing you a different way that you could think of this. So let's take our function. The original function is 2x plus 1 over 3x minus 5. You need to multiply it by negative 1. But watch this, okay? Isn't this the same thing? Okay, look what I did here. Okay, look at this quantity I'm multiplying by. Okay, 1 over negative 1, that 1 divided by negative 1 is negative 1. So the only difference here is now positive 1 is in the numerator and negative 1 is in the denominator. Okay, it's still negative 1 that I'm multiplying by. Okay, so what can happen here is, again, when you multiply the fractions, you're going to multiply the numerators together. You would get 1 times 2x plus 1. And then you would multiply the denominators together. You'd get negative 1 times the quantity 3x minus 5. And in this situation, the numerator will stay the same. But now when we distribute that negative sign in the denominator, every term in the denominator will change signs. Okay, so this is actually an equivalent answer. This is also a correct answer for negative g of x. Okay, after all, we multiplied the fraction by -1, did we not? Okay, look at these two things. Okay, in both methods 1 and 2, we multiplied the original fraction by -1, and these results look different. Okay, but what you need to remember is they are both correct. They are both equivalent. If you got your graphing calculator out and you graphed -2x minus 1 all over 3x minus 5, and then you also graphed out 2x plus 1 all over 3x plus 5, you would get the same graph, okay? They are the same result, they just look different, okay? And one more thing, there's actually a third way to do this, okay? So I'm going to go up here. I'm running out of room, so I'm going to write it up here, okay? There is a third way we could have formed negative g of x, okay? So again, if you're taking -1 and multiplying it by the original function 2x plus 1 over 3x minus 5, the last way that you could do this, and this is the easiest, is you take the original function, the fraction 2x plus 1 over 3x minus 5, and all you do is stick the negative sign out front. Because remember, if you're multiplying by -1, it's the same thing as just having a negative sign out front. So if you write it outside where it doesn't belong to either the top or the bottom, that is also a correct way to do this. Okay, so there's 3 different options for you. Okay, in this class you may certainly run into a situation where you have to multiply a fraction by -1, and I want you to know going forward the correct way to do this. Okay, so again, your 3 options are to correctly multiply a fraction by -1, either change the sign of every term in the numerator and leave the denominator alone like we did in the first method, or you can do what we did in the second method. You leave the numerator alone and you change the sign of each term in the bottom, okay? Or you can just stick the negative out front where that negative does not belong to the numerator or the denominator, okay? So the moral of the story is, you know, if you're multiplying a fraction by -1, you're going to multiply the numerator or the denominator by -1, but not both, okay? And you may be wondering, why don't you multiply the top and the bottom by -1? Okay, if you had done this where you multiplied the top and the bottom by -1, both of them, this quantity, negative divided by negative, would be +1. You'd be multiplying by +1, not -1. Okay, so that is the correct way. Either of these 3 methods, the correct way to multiply a fraction by -1. Okay. All right, let's keep the same original function here. So g of x is equal to 2x plus 1 over 3x minus 5. And in part 2, let's try to form g of x plus h. Okay, so again, this is something that we saw in example 4a. When you look at this, whatever quantity is in parentheses, that is what you're replacing x with. So you're going to go to the original function and you're going to replace each instance of x with x plus h. All right, so here we go. So g of x plus h, okay, here we go. We're going to go to the numerator, okay, so 2x plus 1. Every time you see an x, you're going to replace it with x plus h. Now remember, x plus h is a package deal. You're going to have to put it in parentheses. So we're going to get 2 times x plus h. Okay, so instead of 2x, we have 2 times x plus h. And then don't forget to tack on the plus 1. Okay, that's the numerator. Okay, in the bottom you have 3x minus 5. So when you do the 3x, instead of multiplying 3 by x, you're going to replace x with the package deal x plus h. And then don't forget to tack on the minus 5. Okay, that's it as far as the replacement goes. Okay, now we just need to simplify. So you're going to simplify the numerator and then simplify the denominator. So in the numerator here, we can distribute the 2 across the addition here. So we're going to get 2x plus 2h, and then don't forget the plus 1. Okay, in the bottom, you can also distribute the 3 here. So we're going to get 3x plus 3h. So 3x plus 3h, and then don't forget the minus 5. Okay, so is there anything else you can do? Okay, and you might be thinking, well, okay, I see an x in the top and an x in the bottom. Let me cancel those. Okay, you cannot do that. Okay, that is not allowed here. Okay, same thing with the h's. Yes, you see an h in the top and an h in the bottom, but you cannot cancel them. Why? Because in the top and in the bottom, let's talk about the numerator first. In the numerator, you are adding all these guys together. 2x and 2h and 1, they're all married to each other. You can't separate them because of the addition signs, okay? Same thing in the denominator. You cannot break apart the 3x and the 3h and the minus 5. They're all married to each other with these addition and subtraction signs. You cannot break them apart, okay? So you cannot cancel when you are adding and subtracting pieces. When you could cancel, it would look like this. If instead you were multiplying, if you had 2x times 2h times 1, if you were multiplying these guys together, and in the bottom, if you had 3x times 3h times negative 5, if you were instead multiplying, then you could cancel, and you could say x in the top, x in the bottom, those are going to cancel. And then, oh, I have an h in the top and an h in the bottom, they're going to cancel. If you were multiplying all these guys together, then it would be correct to cancel. But instead, that's not what we have. We are adding and subtracting the terms both in the numerator and the denominator. And so when the terms are attached by addition or subtraction, you absolutely cannot cancel. Okay, so this is as far as you can go. This would be the answer here. Okay, so just remember, going forward, anytime you have a fraction, you can only cancel, if you see something in the numerator that matches something in the denominator, you can only cancel if you're multiplying things in the top or multiplying things in the bottom. You cannot cancel if you're either adding or subtracting in the numerator as well as the denominator. Okay, so this is incorrect. What I have boxed is the correct answer here.